Hello, so today I'm gonna have fun with some data and we're gonna use a database from the Paris City website, which is like checking out all the trees that are in the city. And I had this conversation with a friend that was like, yeah, I got like allergies in some neighborhoods and maybe it's because of the trees. And so I was like, oh, that's funny, let's just map the trees. So we're just gonna do that today. So first, we're gonna import pandas, and what I want to do is show to you the database. It's gonna be French because like Paris City, but we're not gonna be using anything crazy in there. So the data frame is going to be pd.csv, read CSV, my bad. And then the file is called les arbres plantes.csv, and I believe the delimiter here is a semicolon because of French comma separated values, since we use commas for our numbers, so yeah, be careful with that. Let's see what this is getting us. Yeah, Pandas as PD, and now it's working. So here you have our thing. Mainly what we want to do is just take those trees, check out here the species, and then place them on the map. We have coordinates here. We have various informations that we might want to go through, but let's stay simple and let's go next on our project. So first I would just want to have a quick view of our database. So I want to see what the columns are, and they're going to be df.columns. Yeah, and if I don't call it, it's not going to print it. So this is what we have, and let's quickly rename it so that you can read the actual names of the columns we're going to be needing. And so let me copy and paste the modification I did there, and we're just gonna check out those things this way. So now we're gonna have this. I'm gonna replace one column as a count column just because I wanna use it to count stuff, and then we're gonna have the tree width, which is what we're gonna use, and I also changed the name of the species here. And just in case the tree height, but I don't know if I'm going to use it today, just for the sake of doing it. Okay. Now, what I'm going to do is just simply create a renaming variable, which is going to be a dictionary of the zip values of columns and new columns. Why is that? Well, it's simply because when we're going to use the function to rename columns, this is going to be the format that's required. So I'm not going to create it yet and just show the formula, and it's going to be df.rename, and then we're going to rename the columns, and they're going to be the reference is going to be renaming. Okay, and in place is equal to true, meaning that we're updating our database. Okay, but for this to work, we need this thing renaming to be a dictionary of format, like keys being the old columns and value being the new column, the new value. So old value, new value. So that's the format of the dictionary you want to put in this rename columns attribute. And so we're going to do that by creating this renaming variable first, and then adding renaming here. And we're going to just check out our columns to be sure. And we can see that we have name, tree height, tree width, count, so we're all good, we're all set up, and we can keep on going. So let's go and maybe just go with a list of the species we have. So my species are going to be the data frame of name. We just changed that to be like this. Sorry, I'm trying to go way too fast here. And say unique and show it here. Okay, so we've got a lot of things in there actually, and it might be a little complicated for us to showcase everything in there, but I believe if we go up there that actually a lot of values, a lot of species, sorry, are not very common. So what I want to do is maybe just take the trees that you have in quantity. So let's go through that. Let's go and identify the trees that we have a lot of. So we're gonna use a group by method here. So we're gonna say df counts, so tree counts is going to be equal to df dot group by, and in group by what we're gonna do is just use the name of the column we want to group the data frame by, and it's obviously name, so we want to group it by name. But right here Pandas doesn't know what we're going to do when we're grouping. It's going to aggregate everything using the names, and then what operation does it have to do? Well, we're just going to count. And to make it simple, I'm going to add the count column in here, and then the count operation. And maybe that's not clear enough, so you know what? Let me show you what this is gonna look like. df count, just counting and grouping by the column names. Obviously, still always forget to do that. And see that you're gonna get your data frame again, the whole thing, just counting the lines. So every single column is exactly the same because you're counting the iterations of those columns, of those lines, sorry. So what we want to do is just like remove those useless columns, and simply my way of doing this is to just go through my count, the count column I created, and here I get it. Okay, so that's why I wanted to do this to begin with. What I have here, okay, is a list of a lot of values, and you can see that we go from A to T, and what I want to see is things being sorted out. So let's keep on going, and we're gonna say that our how am I gonna do that? Just do a df counts equal df counts dot sort values, and in here what we're gonna say is that we're gonna sort by count, and we're gonna say that ascending is equal to false. Yeah, okay. Okay, here we are. So you can see that we start from Platane at like more than 500, almost 6. Then we drop down real quick to 300, 250, down to 100. And if I do dot head like head 10, yeah, we clearly go like below, yeah, below 30 pretty fast. So maybe I just want to have the top, this like kind of top 10. So 50 and more trees. So yeah, let's do this. So now we're gonna filter our table based on the species, okay? So how do I want to filter a table? Well, what's interesting with pandas is that you can have two different ways of filtering, and to understand how it's going to happen, let me real quick show you how like Pandas is operating. So if I'm taking my df counts here, yeah, let's do this. My df counts, and we're gonna say df counts count. Okay, so that's my column here, is greater than 50. What am I gonna get here? Well, what I'm getting is a new data frame with just Boolean values, and you see that we get true, 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 true until we're equal or less than 50, and then we get false. So the way you're going to filter a database is actually that you're going to pass the database with this list of true and false values. Okay, so now that you have this, what you can do is actually filter things using this filter here. So you've got multiple ways of doing it, but one of the most efficient ones is going to be to actually do a df count dot query, which is like one of the easiest way to do it, and we're gonna say that count is more than 50. So that's a okay way of doing it. df counts, and I keep forgetting that I put a random s in there, but well, okay. But now what I want to do is to just put those names into a list to filter my main table afterwards. How am I gonna do that? Well, simply what I can do is just call the index method of my object. See, it's not a method, sorry, it's a property, because it's the object's index. And so when I do this, I get this list. Okay, if I do type of this, I get a pandas indexes base index, so which is not a list. So if I want to make it a list, what I'm gonna have to do is just transform it with a list call like this, and now we have a list. So that just check out how this list is going. Now we clearly have a list. So this is going to become our target. So our target is going to be this list of trees, and this is what we're going to use, just like we did for the count, to filter the main table now. So we're going to create a table that we're going to call main, and we're going to call our data frame, or the original one, and we're going to query that we wanted to query the data frame if the column name is in my variable target. And in Pandas, in the way to write a query to say that this is a variable, you're gonna add this symbol. Okay, so now it should work. There's another way of doing this. It would be by saying df of filter being the filter here being like count more than 50. So count greater than 50. Okay, so those are the two ways for you to write down the same thing. You've got the query method, and then you've got like just passing the data frame with a data frame or a oh, I'm searching for the name, but well, just one column of Boolean values. We're just gonna use a query here, and what you can see is that we're actually getting it. It's working. We only have the type of trees that we want, and now we can go and analyze stuff a bit more. Next step for us is going to be the separation of those coordinates into two different columns, because right now nothing's going to be able to use it, right? This is just like a random value as a string, and let's check it out actually. So we're going to call the geo.2d. So let's just call my main here of geo.2d, and you see that I get this collection of informations, and if I want to access the row number 4, you can see that this is a string. So what I want to do now is split this string in two and create 2 columns for longitude and latitude, and so that we can use them later on for the mapping. And the way we're going to do that is simply by creating 2 new columns for our data frame, and it's going to be main, and then in here we're going to add our columns, and it's going to be latitude and longitude, and those two are going to be equal to, so main dot geo.2d, so that was it, right? Yeah, I just could have pasted it. So you can call a column as an object of your data frame, because it's just like for the index, it's part of it, and so there are 2 ways to work with it. This is why having this structure with like underscores and stuff is better, because if I had spaces in my titles, I couldn't be using them. So now we're going to call the string functions of our Panda data frame, and this string function is going to be split just like in normal Python. And this split is going to be using the reference of the comma, which is right there. And what we're going to say is, right now we're going to create a list of 2 values that are being splitted. And then Pandas doesn't know what to do with it, so it's going to leave it in this 1 column and nothing will have changed. So what I'm going to say is that I want it to expand into new columns, and so we say expand equal true. And this is why now we know that we're going to populate those 2 columns with those 2 values. If sometimes for some kind of reason you had 3 values in there, you would end up with 3 different values in your list from the split, and then you wouldn't have enough columns created here, and so you would have an error. Okay, so here we are okay, but we're not done, because what we're going to populate our columns with is strings. So we're going to update that by saying that main of latitude is going to be main of latitude, but as type float. Okay, and you know what, let's copy and paste this and say the same thing for longitude, and then copy and paste this because laziness is a thing, and we're good. And then we're gonna check out if everything's working out. So what's wrong here? Geo.2d, what did they... that's weird, because I've got the title here, so it should be okay, but he doesn't recognize it. Geo.2d, let's just copy and paste it and see if some... oh, it's small d, okay. So yeah, there's an error message about this functionality being deprecated or something. For right now, we're okay, and we have our latitude and longitude, and you can see that geo.2d didn't disappear. We just created 2 new values here. Okay, so now we're all set up. We can actually map stuff, and this is going to be the really fun part for me, the actual mapping. So let's go and import Plotly Express. I hope to soon be using something else, but right now I'm trying to understand basic stuff about those maps, so nothing crazy for now. So we're gonna create a figure, and bear with me, I'm just using standard stuff because I can't be bothered, and I copied a lot of stuff from the Plotly website. Thank you, obviously. So we're gonna create a map box here. So what this map box here is a density map box. It means that we're going to express the quantity and the density of trees on the map. So the goal is not to differentiate the different species, it's gonna be to just see where you have more trees, less trees, and maybe like see parks or stuff like that. So let's do this. So what density mapbox is gonna take is multiple arguments. The first one being obviously, well, the data frame, and then the geographical positioning, and we're gonna use latitude. And what's convenient is that we're gonna have the column names that fit here. You have other ways of placing points. I feel like this is the most convenient one for now, so let's do this. Then you can change the radius of your density map box. We can play with that later on to illustrate, but I found that 3 on this is okay. And then the opacity I also played with, and 0.8 is kind of okay for now. So we're gonna say that the colors, because obviously to express the density you need like a scale of colors, right? And so you have preset scales of colors, and here if I use the Viridis one because it was one of the first one I saw in the file I was checking out, and then over hover name is gonna be equal to name, meaning that if you hover over a point, the values that you want to showcase are the names, so the species of the trees. So this is it for our figure, but we're not done, because well, now we're going to update the layout so that the map looks kind of okay. So to do this, we're going to do a figure dot update layout, and this update layout is going to be using a few things. So in Plotly, most of the time you can just use your different functions in a normal way, like adding like the style equal something, but you also can use dictionaries to just like put multiple informations in there pretty fast, and that's the thing I tend to see more. So we're gonna do it this way. So we're gonna say that mapbox is gonna be equal to, so the map area of our graph, which is gonna be like most of it, is gonna be a dictionary. And in here, oopsie, we're gonna say that the style of the map is a standard style, which is called stamen terrain, like this. And then we're gonna say that the center of our map, because obviously you need to tell it where to put the map, and I saw this very smart way of doing it. So again, we're going to use a dictionary, and what we're going to say is that the latitude of the standard map when we open it is going to be our data frame's latitudes average, the mean of it. And that's so simple. Like, we're going to be centered at the mean of our latitude, and you guess it, same thing here. We're gonna be centered at our longitude mean. And like it's this kind of stuff where I'm like, whoa, this is actually really cool. I'm a fan of those kind of stuff. The zoom is gonna be equal to 10. I was playing with it. It feels kind of natural. Otherwise, like, you have the whole world map and it's not really like convenient, and you have to always like scroll every time you reset your map, so it's not really nice. We've got a few other stuff that we can update. So now we're out of our dictionary, and we can say that our legend is not gonna appear because we don't care for this easy of a map. The color axis show scale, so it's just like the legend of the colors, is gonna be equal to true, and my margin is gonna be equal to so I'm gonna copy and paste this. So basically, when you create your map, you have like very big borders, and I didn't like that, and I found out that you can just use margin and put everything to 0 so that this ugly border doesn't show up. So now fig.show, and we should be all set. So I guess there's a high chance that there's a typo somewhere. And no, it's working great. Okay. So now you have your density map box of the trees in Paris. So the settings I used are meant for us to be able to kind of see the city, know where we are, find out about the places. So you can see that we don't really see the parks. So it's actually, I guess, the trees that the city is handling within the streets, within like the common areas, and then parks are part of some other service or some other follow-up. So this is why some species might not be there, but they're actually existing a lot more in parks. And so you can see that there's a lot of platane here, sophora, teal. Cool. So yeah. And if we go back up, like what we can see is that you have a bit more trees around here, which is kind of normal because it's a very touristy area south there. But like the old center is way less populated, and the less populated areas are around here, which is very businessy, if I remember correctly. So maybe less trees in those streets because of the crazy buildings and stores, I guess. So yeah, that's very interesting. I like that. Now let's make a map to see the different species, and we'll be done for today, I guess. So for this one, I'm gonna be using another kind of map, which is actually based on mapbox.com, which is a community created database for your mapping. So I'm just gonna use my token that I hid in a file, so bear with me for a second. I'm just gonna add my token.txt read and as a token file, I guess. And then we're gonna say that token equal token file dot read. There's only the one line, so I don't need to bother with splitting anything. Okay, and here what I'm gonna do is start coding. So if you want to use this map overlay, I encourage you to look into the Mapbox accounts and get yourself an account, generate a token, and then just using the token as a variable here directly. Unless you're sharing anything, you don't really need to do this step. So my new figure, so fig1, is gonna be a scatter map box this time. And what we're gonna do is again use the main data frame. Let me scroll a bit for you here. Okay. And again use as a latitude the lat here, and as a longitude the lon here. And then some changes because we need to say what is going to be the size of our circles, and the size is going to be dependent on my tree width. And the color is going to be depending on the column name. So what did I say here? I said that the size of my the scatter points is going to be depending on the width of the tree, and then the color of the dot is going to be depending on the name of the species. So we're all set for Mapbox, but now we're going to handle the layout of the map. So fig1.update layout, and we're gonna say that map box is gonna be equal to so here I'm gonna add my access token to my mapbox token. Then I'm gonna define the style into the very specific streets, which is looking way prettier. It's the only reason why I'm doing this. Then the center is gonna be a new dictionary of lat main lat dot mean, and we're gonna go with Oopsie. Okay, same thing we've done already. So nothing crazy happening here. You should know what's going on. Let's make this a little bit more readable, like that. The zoom is again gonna be something like 10. And I should be alright. Am I still in my... Yeah, no, this should be here, actually. This way. Okay. Yeah, here we are. I'm sorry, I just want this to be easy to read, easy to understand, so just take a bit of time for this. Then, again, I'm gonna copy and paste my margin up there because otherwise it's really not very nice to look at. Okay, so fig1.show. So, typo? Yes, of course. Styles equals street, and of course it should be column. Okay. And there we are. So you see the difference, like the streets, like the river, everything's way more neat, so it looks like something more conventional. And we have all our points. You can follow some streets. Here you have like packs of marronniers, which is pretty cool. I wonder why just here. But I guess here you have like the famous Place de la Concorde and stuff like that, so I guess it's kind of special. Tilleul, platane seems like it's the thing you put alongside streets, and in my friend's neighborhood, unluckily I can see a lot of species, so we still don't know what she's allergic to. So this is a failure for now, but it's a pretty cool map, and I'm looking forward to make more of those. Maybe things that are more like worldwide, cooler. I've seen like very cool things on Twitter, like with boats, flows, and airplanes like traveling, stuff like that. And I really want to look into this. But you know, step by step, little by little. I'll see you around with another thing, and just keep on coding.